Hello, welcome to mathematics session. We are doing revision. Want to look at the first 4 questions that came in mathematics paper 1 2019. For those who have not yet joined the WhatsApp group, you can send me a message if you want to join on 0977927926 so that you are part of a growing family where you can be assisted individually or as a group. You also take to learn from those who are doing fine so that you improve the chances of clearing mathematics paper 1 and paper 2. So today we want to look at revision, the first 3 questions, indices, quadratic equation, simplification, which is algebra, and sets. So when you are attempting a question or you have been given a paper in mathematics, what should be at the back of your mind is you organize ideas. You need to know where the topic is coming from. Failure to recognize the topic, it means you don't know anything. Organize ideas, important ideas for that particular topic, and also related ideas from different topics, because mathematics is intertwined, is interrelated. You can have, for example, integers. Integers, they are found in most topics. Talk of equation, talk of matrices, talk of gradient, talk of inequalities. You find maths there. Transformation, you find integers. I mean, transformation, you find integers in there. Vectors, you find integers there. So it's not a single topic that you are supposed to focus to say, oh, I'll find maybe quadratic equation only. You need to organize ideas from different angles or different topics in mathematics. So let's begin. Evaluate -1 to the power 0 times 2 raised to the power 3. So this, by virtue of these numbers having powers, this is what? These are indices. So I have to organize my ideas. So what important parts of indices and what gives people problems is, see, a base raised to the power 0, okay, which is equal to 1. So any number raised to the power 0, the answer is 1. Okay, then base raised to the power, certain power like a raised to the power 3, it means multiply the base by itself according to the number of power. If it's 3 times, you say a times a times a. If it's 2, that is a times a. So in this case, this is a raised to the power 3 is the same as a times a times a. A raised to the power 2, it means a times a. So this is what it is. Not, for example, 2 raised to the power 2, okay, or 3, okay. Then you say 2 times 3. This is wrong. So it's 2 times 2 times 2, like this. Okay, 2 times 2, 4 times 2, 8. Okay, so now we look at this question. So I've organized the ideas. So -1 raised to the power 0. So any number raised to the power 0 is 1. So here is 1, like that. Then it times it. Then this one, it means 2 times 2 times 2, like this. Okay, so 1 times 2 times 2, 4 times 2, 8. So 8, like this. So the answer is 8. This is the answer. We look at the next question. The next question we are saying solve the equation x minus 1, open and close brackets, 2x plus 5, okay, open and close brackets, is equal to 0. So where is this topic coming from? It's coming from quadratic equations. So because if I multiply x times 2x, it will be 2x squared. So any equation that has one variable raised to the power 2 is a quadratic equation. So I've organized ideas. The next thing, a times b is equal to 0, meaning one of these, a or b is equal to 0, so that you get the answer 0. So when you multiply 2 times 0, the answer is 0. So any number multiplied by 0, you get 0 always. So in this case, it's the same as a is equal to 0 or b is equal to 0. So either a is equal to 0 or b can be 0, such that when you multiply a times 0 is 0, or 0 times b, it will give you 0. So from this statement, we can say either this expression is the one which is 0 or this one. So you say either x, let me first copy. So we have x minus 1, okay, then we have 2x plus 5 is equal to 0. So we can say either a minus 1 is equal to 0, or 2x plus 5 is equal to 0. So what do? You solve. So this has to go to the other side to make x the subject. So x, which is x1, is equal to, when this crosses the equal sign, the sign will change. So it will be positive 1. Okay? So this is how we solve. Or x number 2 is equal to 2x plus 5. So this goes that side, it will be minus. So it will be 2x is equal to negative 5. Here we have finished, but here we haven't, because we have to make this x the subject. So in this case, over 2 over 2. So there are 2 there. So x is equal to negative 5 over 2, or negative 2 1 over 2. So therefore x is equal to, x1 is equal to 1, or x is equal to negative 2 over 1 over 1 over 2, which is 2.5. So these are called roots. Okay, the answers of this nature, they are called roots. So x has multiple answers. Like it can be x is equal to 1, or x is equal to negative 2 1 over 2. So this is what it is. So this can be either positive or negative. You get the same result. So in this case, this one is positive, this one is what? Negative. So this is the answer. So x1 is 1, then x is equal to negative 2 over 1 over 2. So this is how you are supposed to solve. So as you can see, I'm identifying where the question is coming from, and I'm also generating ideas, important tips that you are supposed to use to solve that particular problem. So that's how you solve mathematics. You can't just solve just looking at numbers. Okay, there are numbers, there's algebra, there's what. If failure to identify where the question is coming from and what they are asking you to do, okay, is the beginning of failing mathematics. So once we do a topic, I give you work in the group. You have to attempt so that you get used, because once you go and you go into an exam room, you open the paper, you know that okay, this what I'm dealing with is algebra, is equations, is simplification, factorization, is travel graphs, and so forth. So we look at the next one. The next one here, simplify. So this one is coming from simplification, which deals with the basic processes of algebra at an advanced level. Remember the algebra you did in grade 8 and 9, 10. Okay, so this is what it is. So under simplification, the most important tip you are supposed to know, one, you need to group like terms together. Grouping. After grouping, now you simplify. Okay, so there will be just minus, plus, and so forth. So the next thing, the next tip number 3, tip number 1, you identify this is simplification. It's coming from basic process of algebra. Number 2, I have to collect like terms together. Number 3, you solve. Number 4, unlike terms cannot be added or subtracted. So let me add this tip. Unlike terms cannot be added or subtracted. So you cannot add or subtract unlike terms. So when you reach a stage where the terms in the expression they are unlike, okay, that's the end. You don't proceed. You don't get numbers and add them since they are numbers. No, as long as one is having a different letter, you can't add. So let us look at this. So the first thing, you identify what is like. So 4x squared, 2y squared xy minus 6x squared minus 2y x. So what are you supposed to do? You focus on letters, not numbers, because numbers without these letters, you can deal with them. You can add and subtract them. So x here, x squared here, we have x squared here. So this one and this one, they are like terms. So I'll say 4x squared. Then this one. So another mistake, people, when you are grouping, they think when they bring it here, it will change the sign. This is not an equation, please. There is no movement from right to left or vice versa. So there is no equal sign here. It's not an equation. So you just pick the sign and the entire number with each variable, each letter. So here is -6. So I'll say -6 x squared. The next thing, that is y squared. Okay, do I have another y squared? Do I have another y squared? Y squared I don't have. Okay, but I have xy. So here I'll just say plus 2y squared. Then here, this one and this one, they are same, xy, xy. They are not raised to any power. Okay, there is xy, xy. So here, -xy. Then this is positive 2xy. So plus 2xy. So here we can solve. Those that I taught algebra, you remember that what this means is that is 4 minus 6. Okay, so in this case, this is 4 minus 6, that is 2. The bigger, the numerical larger number is negative, so here it will be negative. So it will be -2x squared. Then this is plus 2y squared. Then this one again, from here up to there, here there is 1, invisible 1, coefficient, and 2 there. So it's the same as -1, then plus 2, which is 2 minus 1, that is 1. The bigger number is positive, so +1. So +1. So I'll shift this. This is positive. So this positive now, the variables is x and y. So here is times xy, which will give me xy, which is positive. So positive x y. Okay, now when we reach this stage, the first number here is negative, but we have positive values here. So you begin with the positive value. So you begin with this one, okay, or you can begin with this one. This is positive, so we can say positive 2y squared, okay, then negative 2x squared, okay, plus xy. So you begin with a positive value. If you find that the number here after solving it has negative here, you have to take it to rearrange. So this is the answer. The next question is about sets. So shade A union C complement intersect B in the Venn diagram in the answer space. So here, I think I taught this some time back. There is a video for the full shading and description of sets. So shade A union C, okay, in the Venn diagram. So the first thing here, you have to identify A union C. A union C, your A is this one, okay, and your C is this one. So A union C, everything of A and C is this one. So the boundary is from here, okay, you move, then here also you move. So this is your boundary, like this. So this is A union C. Now in this case, they are saying complement. So according to the tips under shading, a complement of a set, you say not part of, do not shade. So this means that do not shade A union C. A union C complement, meaning do not shade A union C. So we are not going to shade A union C. Okay? So now intersection B is what is remaining here. Okay, remember intersection of B is this region from here up to there, but since there is a restriction, once you extend inside there, it's no longer now you have entered into A union C. So do not shade A union C. A union C is this boundary. So since it's intersection, we are going to shade this region. So you shade like this, shade properly and neatly. So you shade like this. So this is it, the answer. So as you can see, the union of A and B is not shaded anywhere. Okay, it's far away. So this is it, what it is. So this is A union C complement, not part of A union C. Do not shade A union C, intersect B. So this is what it is. They can also say, okay, they can also say, so this is the same format or same strategy. We have A, B, C. So they can say B union C, okay, complement intersect A. So how do you shade this? So you identify B union C. B union C is here. So where is the boundary of B? B, okay, you reach at C. C also boundary is here. So you don't shade this B union C. You don't shade this is the boundary. Don't shade. So meaning you are going to shade this part. You are going to shade this part. So this is the answer. So basically, you can even predict next time they may ask you A union C complement intersect C, meaning you are going to shade this part only. So thank you so much for your attention. Once again, for those who would like to join my WhatsApp online group where I teach mathematics, you should do WhatsApp 0977 92 79 26. We'll be glad to receive you and be part of the family. Thank you.